capacities as well, because of which nowadays this artificial intelligence, or let it be data science, this term has become a buzzword. Is used for basically used for explicitly generating content. So the name itself says generative adversarial network. Although name is itself generator, so it will just produce some new data. So generator produces fake data. So this is the agenda for today. Okay. So first we will be seeing what exactly is generative AI. Okay. And then later we'll see what is GAN and how this will be useful in generative AI topic. Okay. So basically generative AI is a concept, and GANs are some deep learning neural network. Okay. Which will be helping us to uh, basically accomplish our goal of that entire project. Okay. So basically generative AI is a concept, and GANs will be helping us to achieve that. And later we will see how this entire thing can be implemented in PyTorch. So PyTorch is a Python library, okay, which basically quite helpful whenever we are doing any implementation, or I can say any model training with respect to deep learning. Okay, so PyTorch is quite helpful for achieving that. So this is the today's agenda. Okay, topic. Okay, so first of all, we'll see what is generative AI. Okay, so it says that generative AI is a type of artificial intelligence that involves the creation of new content. Okay, so this new content term is quite uh, important. Okay, what happens is nowadays many of us are seeing different examples of artificial, and now almost it has become a buzzword. Okay, in entire world. I guess just few years back, if you just go, nobody was talking much about that. But with time, what happened is, we are generating lots of data, and with the lots of data, basically we are having compute capacities as well, because of which nowadays this artificial intelligence, or let it be data science, this term has become a buzzword. Okay, so what happens is, this generative AI is just I would say our domain within the artificial intelligence, which helps us to create the new content. Okay, like already, let's say we are having, let's say, 10 videos, or maybe let's say 50 different people's photos. Okay, so what it will do, basically it will just take those images, let's say those 50 images. So it will just take those images and try to generate a new image, okay, which may not be even existing. So that's the concept of generative AI. This similar thing can be applied to, let's just, a couple of audios as well, videos as well. Okay, so many of you might be knowing the deepfake concept as well. So deepfake is also at the end using the generative AI itself. Okay, so it says that a new content can be created, such as images, music, text, or even video. Okay, by training models on the large amount of data. So what happens is, any I would say practical implementation, or maybe I could say any implementation of data science, or maybe artificial intelligence, the entire basis is the data. Okay, so whatever data we provide to these algorithms or models, okay, how the better the quality of the data, the better will be the output, or I would say training of that model. Okay, so what it says is, first of all, it will just train the model on the large amount of data. Okay, and once it has trained itself, okay, the algorithm has trained itself on the large context, or maybe I can say large amount of data, then it will be able to generate some new images, okay, which might not be existing. Okay, and it says that the models then learn to generate new content that is similar in style or structure to the input data. So the data would be quite similar. Okay, you won't be able to distinguish much. Like, for example, here one image is added. So here, if you see, right now it says that input image, but for the model, lots of images, or basically I can say a lot of data is required. But for example, once the model is trained, now you can see on the left hand side, basically we are seeing a image of an horse. Okay, and that has been converted to image of a zebra. Okay, but if you just see, okay, both the images, it's very difficult to tell, like, which is real or which is fake, right? If you just take a look at this zebra image, okay, it will be quite difficult for us to tell whether it's a fake image or real image. So that's the advantage of generative AI, and I can say that's the power of using generative AI. Okay, like, almost, if you see this zebra image, it almost looks like a real image only. So that's the topic for today itself, like how we can see some realistic images, okay, which can be generated. using the original image. Okay, so this is how this generative AI works. We have just sent one image, okay, for pre-processing. After the model has trained itself on those images, now we can see how this has been transformed. Okay, and it's almost looking a realistic image. So it says that generative AI can be achieved using a variety of techniques, including neural networks. So again, as I said, so generative AI is just a topic, okay, or maybe I can say generative AI is a concept or maybe field of artificial intelligence. But again, I mean, to apply that, okay, or maybe to see the benefits of generative AI, we have to use some technical tools, right? So basically, there are various techniques used for achieving the generative AI concepts. So neural network is one of them. So neural network, for those who don't know much about neural network, so basically it's again a concept in data science which says that deep learning. Okay, so in deep learning what happens, I mean, we define our networks and those networks again learn from the data which we'll be providing for training. Okay, then it says genetic algorithms. So there are a couple of algorithms which are called as genetic algorithms, which are quite generic in nature. Okay, and then Markov model. So Markov model is again, I would say, just a topic, okay, which is existing in the field of data science. So these are a couple of ways with which basically we can achieve whatever we are trying to implement with generative AI. So in today's session, okay, we'll be sticking to this neural network part. Okay, we'll be using neural network to achieve the realistic image generation part. Okay, and it says that these techniques allow the AI to learn patterns in the data and then generate new content based on those patterns. So what happens is, if we use any of these techniques, okay, let it be neural network or genetic algorithm, so any topic, okay, these techniques will help us to basically learn the patterns. Okay, so AI algorithm will learn the patterns in the data and then it will be able to generate the new content based on whatever the pattern it has seen. Okay, so this is just a very brief overview of generative AI. What exactly is generative AI? Okay. Now we'll see what is GAN. Okay. So basically GAN, as I said, so we'll be using different techniques. Okay. It may be one of these, not all of them. It may be one of these, either neural network or maybe genetic algorithm or Markov model. So GAN is a type of neural network. Okay. So we have just mentioned here neural network. So GAN is a type of neural network which is quite specifically used for generation of the content, I would say. Okay, not specific to image or maybe video. So GAN is used for basically used for explicitly generating content. So the name itself says generative adversarial network. Okay, so why it is called adversarial we will see. Okay, but the generative name itself, I mean, explains a lot about I mean, it might be related to generation of some of the content. Okay, so hence the name is given as generative adversarial network. Okay, so it says that, I mean, if you see, look at the image which is just added here. Okay, so for, I mean, for the first row, if you see, all the images are looking quite relevant. Okay, quite related to each other. So this will be our training image. Okay, this first, I mean, first row, first column image will be the training image. But if you can see, using that image, okay, how many different faces, or I would say how many different persons are created. Okay, but if you see, only the first was real, but apart from that no one was real. These are all created, okay, using the help of this. Similarly, you can see for the second row as well. Okay, this was our training image, but based on this particular image, now we can see how many different persons it has created. Okay, so this is the magic of, I would not say magic, at glance it looks like a magic, but at the back end there is a lot of processes going on which is generating these things. Okay, so once you get familiar with data science, you will also be understanding like how it basically generates the images. Okay, there's no magic, there is, I mean, particular science involved in this. And same for the third row as well. So it says that these faces were generated by computer vision technique called as GANs, and none of these peoples are real. Okay, so I mean, if we are able to train the model on couple of images, okay, then it will be able to generate a new images which was not even existing. Okay, so it says that computer vision technique called as GANs or generative adversarial network. Okay, so then hence the name generative adversarial network. So it says that the term GAN was introduced by Ian Goodfellow in 2014. So for those people who are not familiar with this name, Ian Goodfellow, so basically is very well-known data science or data scientist, okay, and he has done a lot of research in the field of deep learning. Okay, so if you just Google his name, you will be able to see what kind of researches he has done and how he has helped the data science to grow, okay, over the years. So this GAN was introduced by Ian Goodfellow. Okay, so it says that data scientists and deep learning researchers use this technique, okay, use these GANs to generate photorealistic image, okay, and then change facial expression as well. So maybe I mean in the recent few years, okay, in the recent few years, you might have seen some fake videos are coming out, okay, on different social media platform. Like for example, a very known person, okay, his video is created, although I mean he was not creating that video, but it was somehow created using the help of other or maybe referencing to some other videos, and those fake videos has basically these hackers and all they have used for wrong purposes as well. So again the basis remains the same, it has used GAN. Okay, so there are advantages of GAN, but there are disadvantages of GANs as well. Okay, so it says that it can change facial expression, create computer game scenes, and visualize designs, etc. So there are lots of applications of GANs. Okay, today we will be seeing how we can use GANs to generate some realistic images. Okay, so now we'll see some theory, or I would say some process how the GANs work. Okay, so it says that GANs learn to generate new data with the same statistic and training set. Okay, so what it says is, again as I said, like algorithms will be using data to learn themselves. Okay, so to get familiar with the patterns, so GANs basically learn to generate new data. There are a couple of algorithms which don't generate the data, we just try to classify the data or maybe predict the new data. But with the help of GANs, we are having advantages of generating the new data. Okay, and what it says is it has same statistics as training set. So when I say same statistic, it means that it will be resembling, okay, it will be quite similar to our training set. Okay, it's not like I mean those two will be quite I mean exactly different. There might be similarity between training data and the generated data. Okay, so it says that GANs consists of two networks playing an adversarial. Okay, when we say adversarial, it says that characterized by conflict or opposition. So basically, there are two networks involved in GANs. Okay, GANs again, I mean it's a neural network, but there are two different networks playing together. Okay, and it says that adversarial game. So when we say adversarial, so basically, they will try to conflict each other. Okay, until and unless there is some threshold at which both the networks will be agreeing. Okay, this is fine. So it says that there will be a kind of game, or maybe the process would be quite in conflict of each other. Okay, so it says that there are one network is called as generator and one is called as discriminator. Okay, so these are two networks again, one is generator and one is discriminator. So there are, I mean these two networks play their own role. Okay, these there are two networks and they both are I mean working in sync, okay, to generate these new images. So these two networks are called as, one is generator and one is discriminator. So the task of generator is, it says generator produces fake data. Okay, although I mean name is it's a generator, so it will just produce some new data. So generator produces fake data and tries to, just a second, and it tries to trick the discriminator. Okay? So discriminator's part is to judge or assess basically whether the data is real or fake. Okay, while generator will just produce the data. So task of generator is to produce the fake data as real as possible, or I would say as similar as possible to training data, and discriminator will judge whether the data is real or fake. Okay, if it is real, then discriminator will say okay, you are good to generate the data. If it is fake, if the discriminator says that it is fake, then what will happen, it will again go for training. Okay, so this is how this entire process runs. So it says that discriminator inspects the fake data and determines if it is real or fake. Okay, and then generator and discriminator are randomly initialized in the beginning and are trained simultaneously. So what happens is, for running any process we have to initialize that, and how it will be initialized, that is also quite important in our field. Okay, at least in data science. So how it will be discriminate or basically initialized, that's quite an important step. So it says that generator and discriminator are randomly initialized at the beginning, and then iteratively they are trained simultaneously with each other. Okay, generator and discriminator. So if you just take a look at these two images in the first, okay, so generator is trying to generate some images which are as close as possible to some digits. Okay, so actually in the data science field, this data set is quite basically known. This is quite famous. It is called as MNIST data. Many of you might be knowing. So basically generator here is trying to generate the images of digits. Okay, so in the first go, if you see, it has generated an image and discriminator says that no, it's not looking like a real, it's a fake image. So here discriminator has said that okay, it's a fake image. So even this will not be proceeding for generator. Right? Generator has again created some of the images, and here discriminator says okay, somehow it is quite closer. Like I mean, first one is looking like 5. Okay, second is somehow looking like a 9. Third is looking like a 0. Here it looks like a 3. So somehow it is quite real. So discriminator says that okay, these are good, at least for the couple of first go or iterations we are good to generate this image. So this is how this entire process runs. Okay,